Okay. So we have to do 3 to the negative 2. Last time, remember, we did this. We had like 2 to the third equals 8, 2 to the second equals 4, 2 to the first equals 2. Your process or your pattern is every one of these numbers is half the one before. So every time your exponent goes down by 1, you take half. So you go down to 2 to the 0. Half of 2 has to be 1. 2 to the negative 1 has to be half of 1, which is 1/2. 2 to the negative 2 has to be half of a half, which is 1/4. And you see, you got 2 here, you got 2 here, you got 4 here, you got 4 here. Okay. So your rule is, of course, this is 1 over 2 to the 1. 1/4 is 1 over 2 squared. So again, 2 squared is here. Your 1 over 2 to the 1 is here. So we have that pattern, and you want to remember that pattern if you want to understand a little bit about negative exponents, other than just the rule. But if you just understand the rule, that's not bad. Okay, the rule for 3 to the negative 2 just automatically means it's 1 over 3 squared. 2 to the negative 3 is 1 over 2 to the third. There's no negative over here. Okay. It's not negative 1 over 3 to the second. It's not 1 over 3 to the negative second. It's 1 over 3 to the second. Your exponent, if you wish, magically changes to positive when you put it down here. Okay. And of course, if you had a negative exponent in the denominator, then you could put that quantity in the numerator with a positive exponent. Those are some of your rules of exponents. They're going to be very important throughout the course. Okay. Well, let's review that fact. Okay. They're kind of okay with that one. So now here we have what I've said is the graph of y equals f of x equals 0.03x to the 4th. Not very well done. Okay. But I said, okay, now we take this thing and we transform it. We shift it right 5 units and up 7 units. And if we do, then let's put our red dot any place we want, but we'll put it right here. Our red dot is right here. It shifts over 5 and up 7. So that this graph shifts 5 units to the right and up 7 units, and all the other points go along with you. Now this would be a vertically stretched x to the 4th graph. And the vertical stretch would actually be a vertical compression because 0.03 is a small number, but we don't worry about that right now. Right now, we're just wanting to get the form of this function. Okay, you don't have to know anything except what a transformation to the right does and what a transformation upwards does. U of x is f of x minus h plus k, where h is your horizontal shift and k is your vertical shift. That's f of x minus 5 plus 7. Those are basic rules for transformations, which was the assignment, I think, due almost a week ago. Okay. So anyhow, g of x is f of x minus 5 plus 7. Okay, now inverse functions. We did this, I believe, last time. We simply take this table and we flip or switch the columns. Okay, so I'm going to write the table down here again. X and y equals f of x. Negative 3, 0, 3, 6, 9, 1, 2, 4, 8, 16. At least you just powers 2 here. And these, if you look at it, are just numbers from negative 3 to 9, skipping 3. So negative 3 and 3 is 0, from 0 to 3 is 3, from 3 to 6, the difference is 3, and from 6 to 9, the difference is 3. Okay, so now we'll do a table of x and y equals f inverse of x. And we switch columns. We switch the column. Okay. Now if we want to do a graph. We're going to want our x values to go out as far as 16. Because on this graph, we do have x equals 16. Over here, let's just go a little higher. We want our y values to go up to 16 because y values on this function go up to 16. Okay. Now, if we've got 16, it's really easy to subdivide. We get 8 here, 4 here, 2 here, and halfway between 4 and 8 is 6. Halfway between 8 and 16 is 12. We got 10 here. We've got 14 here. And we got our units halfway between those numbers. So we can quickly get a good scale. We can do the same thing here. Well, I'm not doing a great job of this. 2, 6, 12, 14, and 10. Well, how long did it take me to do that? Less than a minute. And now I'm in a position where I have almost all of these numbers where I can locate them on either end. Now, I am going to need a negative 3. So, well, if 2 is here, and 4 is here, 3 is here, so negative 3 would go this far on this side of the axis. And negative 3 would go down here on the y-axis. So we can include that. And then, of course, we can do negative 2 and negative 1. And I've got a reasonably scaled graph. Okay. Numbers are pretty equally spaced. Not perfect, but close enough to get the shape of the graph. Okay. So first graph, when x is negative 3, y is 1. There's negative 3, and here's 1. When x is 0, y is 2, that gives me this point. But x is 3, y is 4. So x is 3. Y is 4. When x is 6, y is 8. So y is 8 out here. X is 6 on this line. There we have it. And when x is 9, y is 16. So here's the line where y is 16. And here's the line where x equals 9. So we have these points. And this kind of looks like an exponential graph, actually. It is an exponential function. It's not our basic toolkit exponential function, but it's an exponential function. Okay. Now we plot the inverse. Okay, now when x is 1, y should be negative 3. So here's x equals 1. Here's y equals negative 3. So we get a point here. When x is 2, y should be 0. So when x is 2, y is 0. When x is 4, y is 3. So here's where x equals 4. And here's where y equals 3. X equals 8, y equals 6. Okay, x equals 8 on this vertical line, y equals 6 on this horizontal line. It'll be about here. And when x equals 16, y should be 9. So here's 9. Here's y equals 9. Here's x equals 16. And we have these points. So here is the graph of the inverse function. Okay, that's kind of some sort of a symmetry there. I mean, there is a symmetry. The line y equals x splits this graph in half. Every point is reflected across this line to the point of the other function. Every point of the inverse function reflects to the point of the original function and vice versa. And this is because we've switched the roles of x and y. If we switch our x's and y, that's going to happen. Now, see more about that in the pre-calculus class. Here in my class, it'll be somewhat later, a couple of weeks at least. And in the other class, other classes, you might have already seen it. There it is, kind of a summary. If you happen to be, gonna do this. Okay, let's say that now. Now, this has nothing to do with these graphs, but if y equals f of x equals 2x plus 3, what is f inverse of x? Well, start with y equals 2x plus 3. Now, what did we do here? We switched x and y, right? X became y and y became x. So x equals 2y plus 3. Solve for y. I'm going to stop here and ask everybody to solve that equation for y. Okay, we're trying to solve this equation for y. We have x equals 2y plus 3. We can subtract 3 from both sides, and then we won't have the 3 there anymore. And we'll just have a 2y on this side. So we're going to be closer to isolating y. Now, what I'm going to do first, though, I'm going to write this as 2y plus 3 equals x. Just switch the two sides, which doesn't change anything. If this is equal to this, then this is equal to this. They're equal. Okay, we just change the side. Now I do 2y plus 3 minus 3 equals x minus 3. And I get 2y equals x minus 3. Because 3 minus 3 is 0. Okay, now I can't subtract 2 to get rid of this 2. I have to divide because it's multiplied by 1. And if I divide 2y by 2, I just get 1y. So I get y equals x minus 3 over 2. That's the inverse function. Then, you got a little bit of room there, I'm going to use it. So, y is f inverse of x, because how did I get this equation for y? I switched the x and y from the f of x function to get this equation, then I solved it for y. So now y equals f inverse of x equals x minus 3 over 2. Now we can check this. F of f inverse of x is 2 times f inverse of x plus 3. Because f of x is 2x plus 3. So if instead of x, I write f inverse of x in parentheses, then I've got to make this into f inverse of x. There's nothing mysterious about this. We're just replacing x both places with f inverse of x. Now, of course, f inverse of x is x minus 3 over 2. So my expression f inverse of x is replaced by x minus 3 over 2. If I multiply 2 by x minus 3 over 2, I get x minus 3. Adding 3, I just get x. So that checks it. So there's another part that you have to check. See whether f inverse of f of x equals x. If you have inverse function, either way you do the composite of the inverse, you get x. So there's a simple case of how you solve for an inverse function. Now it can get very complicated. We get a little complicated in this course. So we do a little bit more algebra. Okay. But we're going to have the algebra of solving a linear equation. We've got to be very used to that, and we'll make sure we get that right. Thanks, folks. Okay. Let's just take, actually, I want to start with this. Sorry. We want to take y equals 2x plus 3 and plot it. Now, we don't usually plot functions in this class by plotting points. We usually do them by transformations. Okay, but if the function is complicated enough, you pretty much just have to plot points. Actually, if it's complicated enough, you pretty much have to use a graphic calculator so you get a reasonable graph. There's only so much you can see, only so much I can see. I can see more than you will. But give me a complicated enough function, I won't be able to keep enough information in my head to figure out just how that function is going to behave. Of course, I can apply calculus and a lot of other stuff to graphing and understanding proportionality and stuff like this. And we're going to learn some of that, but you're not going to learn all of that. Okay. So my point is, sometimes you got to plot points, but usually you're going to use transformations. Okay, if you got y equals 2x plus 3, though, we make a graph or table. Let's just say we're going to let x equal -2, -1, 0, 1, 2. Okay. So go ahead and fill in the right-hand side. plug in each value of X into that equation and see what Y is. Okay, well, not everybody appears to know how to do this, but some do. So either you do or you don't know how to do this, and if you don't, you might as well watch me do it. Okay? If X is -2, then Y is going to be 2 times -2 plus 3. Now, if I just replace X by 2, and then I do the calculation. And you do that calculation, you come out -1. Then, if X is -1, you're going to put -1 in for X, and you're going to get 2 times -1 plus 3, and that's going to equal 1. Put in 0 for X, you're going to get 2 times 0 plus 3, and that's 3. And you put 1 in for X, you get 2 times 1 plus 3, which is 5. And then you put in 2 for X, you get 2 times 2 plus 3, which is 7. So now you can get the graph. Okay, for X values go from -2 to 2, so we'll put -2 here. We'll put 2 here. Y values go from -1 to 7. Well, I'll extend the y-axis a little bit. I'll put 8 up here. Now, the scales are different. You know, from here to here is only 4, and from here to here is 8. So y has a different scale than X, but we can do that. As long as we are sure we know what the scale is. So here we have, of course, -1 and 1. Here we're going to have 4 and 2 and -2, so that we can plot these points. If X is -2, Y is -1. So if X is -2, well, -2, X is -2 on this line, -1 occurs here on the y-axis. So we've got a point right here, right over my label of -2. Okay, if X is -1, Y is 1. Okay, well, here's where X equals -1. Here's where Y equals 1. And here's my point. Okay, if X is 0, Y is 3. Well, here X is 0, here Y is 3. When X is 1, Y is 5. Well, okay, there's 4, there's 8. 6 is halfway between, so 5 is here and 6 is here, or 7 is here. And we get this point. And then when X equals 2, Y equals 7. So that would be a point about here. Now this point, my -1 was over a little bit too far. This point isn't absolutely perfect, but we pretty much get a straight line through the point. Okay, so Y equals 2X plus 3 gives us a straight line. The slope of this straight line we can get in a fairly simple way. We just take 2 points on the line. So I'm going to take a point, say this point, and this point. Now I'm going to draw the line segment between these points. Then I'm going to draw a path from this point to this point, where I go in the horizontal direction for part of the path, in the vertical direction for the other part. So I'm going to go in the horizontal direction here. And then I'm going to go in the vertical direction here. And I put on the heads, make these into arrows. Okay, So this arrow, well, what's the length of this arrow? Can you show me with your fingers? How long is the arrow from this, the horizontal arrow from here to here? Hold on. Okay, so again, how much does X change from this point over to here? How many units? Well, what's the X value here? -1, isn't it? And what's the X value over here? Well, it's clearly 2, right? So if we go from -1 to 2, how far do we go on the number line? Okay, now people aren't understanding my question, so we go to a number line here. And I just mark this off. You can think of this as the interstate with, these are mile markers. Mile markers from 5 to 12. Well, we're right out in front of about mile marker 15, okay? So, here we are. And this is just a little ways down the interstate. Now, if we go from mile marker 6 to mile marker 10, how many miles do we go? Well, people tell me, yeah, 4 miles. That's pretty obvious. Now, if we went from mile marker 17 to mile marker 328, well, you might have to think about that a little bit. You might have to even use a calculator. Hopefully not, it's not that hard of a calculation, but if you do, that's okay. Okay, now, we got the x-axis marked from -2 to 2, right? Okay. Mile markers aren't -2, -1, okay? But you can think about it. You can think, let's say that, okay, the interstate out in front goes down to 2, 1. 0 would be the state line, wouldn't it? Now, that's not completely accurate because the state line doesn't occur right at, well, yeah, the state line does occur at 0, okay? That's the state line. Then we're in the numbering the next state down, right? It'd be Tennessee in this case, okay? So we're right at state line going into Tennessee. Well, we don't number them -1, -2, -3, -4, but we could. People in Tennessee wouldn't like it, so I guess we probably shouldn't. Okay. And, there's their number in the same direction already. So, you go down, Anyhow. So if we were at -1, if we used our numbering for Tennessee, we'd have a mile marker -1. Now, if we go from -1 up to 2, how many miles is that? Yeah, we go from -1 to 2, how many miles? It's 3 miles. You count them. 1, 2, 3. Okay. Now let me just observe. This arrow is and -6 is 4. That's in the positive direction, because that's the direction the x-axis points in, and that's the direction of increasing numbers, right? Numbers are getting more and more positive as you go this way. Here, you get 3. The calculation would be -2 -1. Of course, that means 2 + 1. And that's 3. It's a bad abbreviation of horizontal. Horizontally, we go 3 units, and it's +3, 3 units in the positive direction. Vertically, how far do we go? Well, we start where X is 1, because Y is 1, where this arrow crosses the Y-axis and the arrow is horizontal. So Y is still 1 at this point. So we're on the line, if you wish, for Y equals 1. Now, what's the line that we're on when we get up here? I don't like what I read in that thing. This label right here, Y equals 1. And up here. Y equals 7. So we're going from Y equals 1 to Y equals 7. So vertically, it's 7 minus 1 equals 6. We go 6 units from Y equals 1 to Y equals 7, it's 6 units. Well, we're going to call this arrow the rise. We're going to call this arrow the run. Rise is 6, the run is 3. The slope is the rise divided by the run. That's something you always want to remember. That's what slope is between 2 points. Rise divided by the run is 6 divided by 3, which is 2. I'll just put a little box around the 2 and put it on this leg of the triangle. Indicate, the box just indicates that this is the slope. This is the rise, this is the run, this is the slope, and here's how I calculated the slope. Okay. Now I'm going to give you 2 points in a graph. This point is going to be 3, 1. I'm sorry, 1, 3. You do that in reverse thoughts. Gotta be careful. And this point will then be 7, 7. So can you copy that down? And then make your line segment joining those points. Should have been looking at that point. I didn't quite get it. You understand what I mean? And then draw a horizontal arrow and a vertical arrow for your run and your rise. Okay. So we draw a horizontal arrow. Let's just draw a horizontal line through this point so we know where the arrow goes, and then a vertical line through this point, so we can easily draw a good horizontal arrow. It comes up to the line that right below this point in the vertical arrow. Okay, so those are our two arrows. Now, how long is this arrow? How long is this arrow? And is it in the positive direction or negative direction? Well, they're both in the positive direction. You can see that. Figure out how long this arrow is. I'm going to draw this vertical line along with this one. Okay, this vertical line goes through the x-axis where x equals 1, and this one goes through the x-axis where x equals 7. Because, of course, x is 1 at this point, x is 7 at this point. That means a vertical line through this point will hit the x-axis at x equals 7. Since your first coordinate is 7. First coordinate here is 1. That means a vertical line through this point hits the x-axis where x equals 1. Similarly, a horizontal line through this first point means that that's the line where y equals 3. So we can put 3 here. And y is 7 here. So y is going to be 7 at this point on the y-axis. We could even label these lines. This line is x equals 1. This line is x equals 7. And that can be helpful. This line is y equals 3. This line is y equals 7. Okay. Well, how far is it from here to here? Well, this distance from here to here is 6 units, isn't it? This arrow would be 6 units long, so this arrow is 6 units long. Since these are vertical lines, the distance from this point of this line to this point is the same as the distance from here to here. So we can say, how do we get to 6? Well, we can say now the run is 6 minus 1. 7 minus 1, I'm sorry, equals 6. And you want to write that in to reinforce it. And here, seven minus 3, I keep that in my result in my calculation. Rise is 7 minus 3, which is 4. So we label that so that we really reinforce what we've got. Now, in my class, I require that labeling. I call that a fundamental triangle. Other classes don't use that terminology and maybe even rely on the formula that people memorize and forget later. Okay? I think it's easier to reinforce and understand what it means if you draw this picture and label everything. And then I don't have room to calculate it over here because I did this kind of a small area before, but the slope is rise over run. And we're not dealing with y equals 2, it's 3. That equals 4 over 6, which reduces down to 2 over 3, 2/3. And I'll put the 2/3 here, emphasize that it's slope. And if you always label these things, or at least do this a number of times with pairs of points. If you're in my class, that'd be an important thing to do because I actually do that in a test between 2 points on the graph. If you're not in my class, well, that's not required. If you think it's a good idea, if you think it'll help you focus on what slope means, instead of using a formula to get the answer quickly and maybe not retain it, then consider it a useful exercise. It's not required for this class, though. It's not required in your class. And if you're not in my class, it probably isn't. Then it's just a mechanism for illustrating and understanding, and you can take it for what it's worth. Okay. Now, let's come back here. Hopefully we understand slope. Now let's come back to this function in this table. If you graph this carefully, you find all the points on the straight line. Okay. Then you find the slope between any 2 points of this line is always going to be the same. It's always going to be 2. Okay. Slope between any 2 points on the graph, if the graph is done accurately, has to be 2. And look here. But here is the slope. Now, if you're in my class, you've seen a lot of graphs and none of them are straight. Okay. For too long, we'll see 2 more. In my class, we'll see 2 more basic shapes. One is a straight line and one's an absolute value. And they're really easy to construct. Okay. So they're so simple that I haven't talked about at this point. But we can do the same stuff we've done. Now, if you're not in my class, you don't know what I'm talking about. But yeah. Most of the people who are attending are in my class, but there's some distant students that seem to be doing pretty well. And they aren't in my class. Okay, anyhow, slope of the line is this. Slope of the line is this number in front of X. Okay. Now, the other thing is, let's observe that the graph crosses the y-axis. You might not be able to read that word. It says y-intercept is at the point 0, 3. And of course, that happened to occur right here in the table. When X is 0, we know that Y is 3, right? And the y-intercept occurs when X equals 0 because the y-axis is the X equals 0 line. Well, where do we see that 3? Well, it's right here. There's the slope of the line. Here's the y-intercept. Okay, now I'm going to ask you to figure out this equation for another line. Here's a line. Passes through the points. -6, 0. And 0, 4. So what we know is the x-intercept and the y-intercept. So M is going to be the slope, B is going to be the y-intercept. So figure out the slope. You've got 2 points, you know what their coordinates are. Draw the triangle, like I did. Label it just like I did. Calculate its slope. And if you're not in my pre-calculus class, go ahead and calculate it any way you choose. Kind of recommend drawing the triangle, labeling and stuff, because it gives you more meaning. But it's not required of anybody in this class who's not in my calculus class. Okay, well, when these 2 points, I draw a straight line, draw a couple of arrows, and I determine that this arrow has a length of 6. And this arrow, this length is 6 in the positive direction, so I'll say it's a +6. This is 4 in the positive direction, so I'll say this is a +4. So that the slope equals rise divided by run. I don't see people actually writing out all the words that I write out. In my class, you definitely want to do it. You're going to have to write them out. Okay. Want to see all the words. You're not. Make your own judgment as to what way you learn this best. And not just for short term. You learn it best for long-term goals, for the ability to be able to do this on the final exam in a few months. Okay. Okay, so rise over run anyhow is 4/6, which is 2/3. We've already seen another example with a slope of 2/3, and I put it here. If people don't want to do all these details, in my class, you want to do all these details because you don't need to. Okay. Then what the equation is, y equals mx plus b. From this construction, m is 2/3. I've written all the details out here, so I don't have to do anything but just say, okay, look at the construction. It's all labeled. Everything is there. I see exactly how I got it. Okay. M is 2/3. What's b? Show me the figures. Yeah. B is the y-intercept. That's 4. Now, give you any x value at all. This line goes on forever. Any x value is going to give you a y value. X equals 793.8726. You just put it in here, calculate it, and you get y. Okay. And if you want to find where y equals 382, you put in 382 for y, and you have an equation that you can solve for x. You subtract 4 from both sides, multiply both sides by 3/2, you're going to get x. But you have to know how to solve equations. Okay. Well, there's a lot more I could say, and I wish I could go into more detail on this today, but we had to make sure everybody thoroughly understood at least this much. Now, the assignments in this class for next week, we're easing off a little bit on the assignments, but it'll have to do with slope and equation of straight lines. Okay? We're going to do more of that. And the one assignment you have is for next time is just the assignment on linear functions. Okay, I'm gonna just tell you what some of the scores were. Got 20 out of 30 on this one. First three graphs were good, well done. Last two graphs, got a little confused, and didn't really have the rules for those two graphs, but it's just a matter of get the rules. No question you can do it, but make sure you spend the time on those. And exponential graph, pretty well lined off, but started in the lower left-hand corner of the rectangle, and didn't have quite enough horizontal lines. Start in the horizontal line on the left edge, just above. Review the directions. Make sure you have all the details. Square graph looked real good. Reciprocal graph looked really good. 15 out of 20 in that one. 15 out of 30. Now, of course, 15 out of 30 is a low pass, actually. Okay. 20 out of 30 is a halfway respectable. Okay, but make it totally respectable. Okay, see a good reciprocal graph looked pretty good, but there weren't enough lines, and it was more like a reciprocal square graph. So also your lines on that graph are the same as the lines you use on the squaring function. So make sure you know how to line this thing. Make sure you know what the rule is. It's pretty well drawn. It's got the right shape for reciprocal square. And then a reciprocal square graph looked a whole lot like a cubic graph. Okay. Exponential graph looked great. So 10 out of 20 in that one, and potential to do it completely right. You got one here that none of the graphs were constructed, couldn't give it any credit. But there's progress because most of the shapes look pretty good. They weren't all labeled. And I think I saw the construction lines go in after the graphs were drawn. You got to draw the construction lines first with the points on according to the algorithm. So got a little work to do there, but getting there's stuff going on there. Doesn't look terrible, but it's got to improve. And got one that was everything's perfect. Another one got a good squaring graph, and then a couple other graphs. I'm not sure what they're supposed to be, but right general idea. Okay, so that's what I'm seeing. Okay, better let you take a quick look. You don't have a lot of class time. Okay, so I'm going to give them back to you. Give you about a minute to just look at the notes I've jotted, and I'm going to need them back. Then if you want me to give you these specifics, just email me and ask. I'll take this thing and I'll tell you specifically what you did wrong, what you did right. Okay. I just jotted down a couple of notes, but your references, the videos or the instructions. Actually, I've written another thing for you that I'm not sure I've posted, but I've got a sample test for you too. Okay. Then we'll talk about that, but give you these back and let you look at it for a minute. So, okay, so that wasn't perfect, and you've had time to make it perfect. You have to practice, but there's progress. I think what I see here, everybody can do it. If you sit down with a stopwatch, time yourself, follow all the directions, follow my advice. My advice has been, make sure you know how to draw it. Watch the video, get the directions, follow them, do the graph, match it up with the graphs you see me draw or whatever. Okay. Until you can do that, then put the directions away and start drawing them until you can draw all 5 of them in 10 minutes. Okay. Now, a lot of people drew 5 graphs in 10 minutes and they were often mostly right, but the perfection is the thing. How to make perfection and making your drawing real pretty. You don't have time in 10 minutes unless you're very good at drawing. Okay. I mean, You see what I draw, you know, most of you draw better than I can. But you know, I've got to, if the lines are twice as close together, they got to be twice as close together and stuff like that. If they're supposed to be twice as close together and they're evenly spaced, no, you weren't following the construction, okay? And just for reference, if I'm going from top to bottom and I'm going twice as close to the bottom each time, I call that an edge subdivision. And maybe 4 steps, maybe 5 steps. Okay. The center subdivision, you divide it in the middle and go halfway to the center from this side, halfway to the center from this side, whatever number of steps. Okay. And that's really pretty much it. Now with the cubing function, you get a lot of steps. You get so many steps, there are 2 lines that you need to have that you can't draw. But you just understand that they're there so that you can follow the algorithm. I'm just looking at these real quick. I might not look at all of them. I'm only going to take 5 minutes or less on this. See. Any comments? Yeah, see some function notation. So people often get started right on function notation. You should be able to do function notation because we've used it in class for the functions that we draw in arbitrary rectangles, okay? So you should be picking that up. So I see one here where the first couple were okay. After that, got a little confusing. Well, that's understandable at this point. But I'm going to get over that. And then we solve a linear equation and that looks good. So now I'm not saying whose these are, I'm not even necessarily reading it. And we got an inequality, it's graphed. Not a bad attempt. Simplify. A little rusty in the algebra, but doing what looks like valid steps, but not necessarily at the right time. So we've got to upgrade, get the rust out from the algebra. But that's the case. That's what I expect. Unfortunately, it's what I have to see in any pre-calculus class. And this really helps because it shows me what you need to do, what you need to learn to do. Say right idea, but an incorrect cancellation. See an awful lot of that. Pretty much, there's a way to cancel incorrect, we'll do it. Interesting approach at that. Looking pretty good. Solving a linear equation. That was a hard problem. So I don't pay too much attention to that one, but I like to see if people can solve it. Okay, so it's in there, but very seldom does anybody solve that one. Okay, well, what I see on these is we're gonna have to spend some time on algebra. What is this doggone camera? Zoom back to the interstate so that, you know, we all look like ants in an anthill. I mean, we don't have a physical resemblance. We look about that big. It just kind of resets itself. So there I am. Which is okay, kind of unfortunate for the appearance of the video, but okay. Let's see, now we got to focus. Well, it didn't actually manage to focus itself. Okay. Okay, now I have something else for you. least we had it at one point. Oh, yeah. We'll let you look at this briefly, and then we're going to kind of go over it, because it's a sample of problems that are going to be on the test. Okay, now what you see here, these things are numbered. You see this 001 thing? That's exactly what you did on the quiz today, right? The very first problem. Construct graphs in detail. Okay. And be sure to include the red dot and construction lines, because that's what you use to draw the graph. Okay, so there's no surprise on that one. It will be there. Okay. Now, right now, I haven't balanced this out. Okay, so you have problems 011 through 014. They're all the same, except that they're different. What's different about problem 011 and 012? Most of the words are the same, but what's different? Okay, so if we look at 011, 012, 013, 014, the only difference is which function. First one's exponential, second one's squaring, third one's reciprocal, fourth one I think is reciprocal square. That's the pattern for all of these, except the last one. Okay. It's the same question, but with slightly different numbers. And with different functions. I'm not going to ask you all four, but if this series appears on your test, it'll just be one of them, and it's going to be randomly selected. Okay, so there'll be a 25% chance of each one. Okay, then you got 021 through 024. Same thing. You can see what it's asking you to do. And I'll give an example of each of these. Okay, then same with 031 through 034. Just the only thing that differs is the numbers, which differ from version to version. This is version 1 of the test bank. Okay, the test is generated by random selection within the problem groups from 100 versions. Okay, if I wanted 1,000 versions, it would run it in 10 seconds or less. 100 is sufficient. Nobody's going to be able to figure out what the numbers are going to be. Okay. Now you get down to the 05, and it asks about domain and range. We talked about that last week with the pictures. And there are only 3 of them I ask about, because I don't ask you about the square function. I ask you about the exponential, reciprocal square functions, because their domains are more complicated. And with the squaring function, it's just, there's nothing to it. Okay, and with the cubic function, although I might throw a cubic function in there. I haven't made final decisions. Okay, so let's look at what these problems are asking. The first one, of course, is sketch all those shapes. And you won't have a time limit. You can take as long as you want, but you don't want to go into the test having to take an hour to do the 5 shapes. You need the time for the other problem. So you ought to be able to get that first problem out of the way in 10 minutes or less. Okay. And if there are 5 problems, I'm not going to guarantee there are 5 problems, but if there are 5 problems, then 10 minutes a piece is enough. Okay. And there's nothing really complicated about any of these. Now, most of these you're going to want to redraw the shape that you get. But that shouldn't take you more than a minute or 2, because you've already drawn it. Okay. And sometimes you could say, okay, look back, and I did this on the graph I constructed for number 1. Okay. And Now, see, you say yourself having to draw it, maybe. Okay, now on the first series. What are we asking you to do? I better look and make sure I know what I asked. But I want you to label this thing in a 4x4 rectangle with the red dot at the origin. We did that last time. And that's what gives you the basic toolkit function. Okay? The basic toolkit function for every one of these is the one with the red dot at the origin in a 4x4 rectangle, except for the cubing function is in a 16x4 rectangle, which you'll understand if you've seen everything you're supposed to see. Okay, and that's one reason I kind of left the cubing function off, and I thought I'll let you know Thursday, well, I'm really leaving the cubing function off. That gets a little confusing. Everything else, all the four others can all be done in a 4x4 rectangle. Okay. Now, if I said do a cubing function, I'd say do a 16x4 rectangle. Okay. On this series. So I'm not going to say a lot about this because there's not that much to say. Okay. You sketch it. Sketch a graph against a given function with a given shape. Then that shape sketched in the 4x4 rectangle becomes your function. Okay. So I want to talk first about shapes, but examples. I need a close one. I need something to skip if I'm going to do the reciprocal or the squaring function. Okay. So I have a point here, and I'm not going to draw all the points. But a point here. Here I am. Go down. I'll go over one and skip one. Go over one and down two. Over one, down two. Over one, down two. I can't go down two unless I've got that fifth line in there. And the red dots at the origin. So if I'm doing the basic squaring function, the toolkit, basic toolkit squaring function, that's it. And if the red dots at the origin, then this is the y-axis. This is the x-axis. The x and y-axis always go through the red dot. That's why we got a red dot. That's why I invented the red dot. It's my invention. I patented it. Anybody that uses it's got to pay me a lot of money. But y'all can use it for free. As long as you're not making money off of it. Okay. But seriously, I incorporated that red dot so you'd have something to focus on. So you would understand when we get to this, that's where the x and the y axis go through for the basic toolkit function. Okay. I didn't use that term.
Right.
On the test. Probably won't. I could incorporate it. Just kept it as simple as I could, so I don't confuse you with terminology, but that's what the terminology means. Okay, for the first four functions other than the cubic function, the 4x4 rectangle with the red dot at the origin. Now, once we know that, we can label all the construction lines and the edges. Of course, that's implicit. X has got to be -2 here, and X has got to be 2 here, because X is 0 on the y-axis, which is something you really want to get used to. People keep losing track of the fact that X is 0 on the y-axis and causing no end of trouble, okay? Yeah, you'll understand later why that's important, okay? So there we got X equals -2, X equals 0, X equals 2. So we can easily see that if we do this subdivision, you know, halfway between here and here, this is X equals -1. This is X equals 1. Then you got X equals 1/2. You're gonna want to label. I didn't leave myself room to label. You label. Okay, and you label your y. Y equals, what's y equal here? Show me with your fingers. What's y equal to here? I'll give you a hint. This is a 4x4 rectangle, actually a square. And it's 0 down here. What is it up here? 4. Okay, now if the red dot was in the middle, it'd be 2. I saw some 2s there, and that happens. As a reciprocal function, that happens. And for the cubic function, that happens. Okay. It's not 2 from the cubic function because it's a longer rectangle. Okay, so anyhow, y is 4 here. That should be a no-brainer, and if you haven't thought through that, you haven't followed all the instructions. Okay? So think through that. Follow all the instructions so you think through that. So you get to the test and you immediately see, okay, that's got to be y equals 4. Okay? On this first series. And then y equals 2 here. Y equals 1. Y equals 1/2 here. Y equals 1/4 on this next line. Might be hard to see. And then this really close one, y equals 1/8. You don't actually use that point, but it's got to be there so you can skip it. Now, comment when you do the cubic function, you're going to need like 10 lines on each side of the center. Not quite 10. Okay, there's so many that you no way you're drawing the last 2. Okay, but they're there whether you can draw them or not. All you got to do is say they're there. I drew them, but they're almost inside the other line, so you probably can't see them. And I'll believe you, even if you didn't draw them, because you can't draw them. Okay, unless you got a huge piece of paper. They're so close to the x-axis that there's no way you're going to draw them. Okay, but they got to be there because the rule for the cubic function is over 1 and down 3. You get down to the lowest line you can draw, which is really close to the x-axis, and then you got 2 lines, one twice as close, one 4 times as close as that one, to skip before you get to the red dot. Otherwise, you don't hit the red dot, and the algorithm doesn't work. Try to understand that. Okay, but it's not a big deal here because I'm probably not going to ask you to do the cubic function at this point. I might see if I can do it. Give you a little extra credit if you can. So it would be worth knowing how to do. All right. So for the squaring function, there are your labels for the construction lines. Follow the algorithm. Start upper left corner, over 1, down 2, over 1, down 2, over 1, down 2, then over 1, up 2, over 1, up 2, over 1, up 2, and you're here. That's it. If it's a reciprocal square function, where do you start? Now there's one that people were a little shaky on. They did this, okay? But the reciprocal square function starts at the, well, you do 4 lines instead of 5. You do 5 lines for the squaring function. You only do 4 lines for the exponential or the reciprocal square function. You'll do that when I summarize the rules. Okay. So you start at the line directly. You do 4 subdivisions here vertically. Halfway, 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 halfway. And you're done with the horizontal line. You go to the first horizontal line above the axis. You put a point there, over 1, up 1, over 1, up 1, over 1, up 1, and you've got it. Okay. So, similar subdivision, but you don't do that last little line. And I'm not gonna go over every one. You're fine. It's not a wide angle lens. Because it gets to about here.
Okay, that's what I'm sure.
But thank you. Okay. Hopefully that makes sense. Because you'll pretty much know how to draw at least a square graph. Okay. Reciprocal square and in the exponential graph, you did pretty well on those. Not everybody, so you got work to do, but there it is. So that's what you do. Then you make a table. And we did that last time. So let me do. This is the example of a reciprocal square. Reciprocal square. The red dot is at the center of the lowest edge. You do the usual subdivision. Everything is the exponential, you subdivide twice on each side. Okay, so that you have 5 lines. For the exponential, you only subdivide once on each side, so you only have 4 lines. You're getting that. So that's good. And then we have just 4 lines. 1, 2, 3, 4. Okay, you got y equals 4 up here. The x-axis is down here, and that's where y equals 0. So this has to be y equals 2, since it's halfway between 4 and 0. This is y equals 1. This is y equals 1/2. And this one over here is y equals 1/4. What's our rule? We start on the left edge, on the first line above. Now, we've got that in writing, we said it a number of times. Make sure you're straight on that, because it's common to want to start in the lower left-hand corner. It's pretty natural. That doesn't mean it's right. Okay, that doesn't mean if you start there, you're not going to get penalized, right? Because you're going to have something really screwed up when you make your table. As we'll see in a minute. Okay, then we just move over 1 up 2, over 1, over 1 up 2, and we're done. We're at the top. So we don't move over here and up 2. That doesn't work, because we'd have to have a line here that's twice as close as this one, and we don't. And we don't need it if our graph is confined to this rectangle. Square in this case. Then we start at the line just to the right of the center on the upper edge. We go over 1, down 1, sorry, over 1, down 2, over 1, down 2. We don't end up on the x-axis. If you end up on the x-axis, you're going to be very misled about the way this function behaves. It never gets to the x-axis, no matter how far you extend it. And it never gets to the y-axis either. We'll make that clear. But right now, just be able to draw the thing accurately and make the table. Now, what are the coordinates of these points? If you've drawn it correctly, that's really easy. Well, I haven't labeled all the lines. Okay, so here's the y-axis. X equals 0, and that's the y-axis. X is -2. Clicks on the board there. It's not the reason my 2 is so bad. That's because I wrote a 1. But x equals -2, x equals -1, and x equals 1/2, -1/2. Is this line. Okay, then over here we have x equals 1/2, x equals 1, and x equals 2. Not every line is labeled, so we can label the x and y coordinates. you know, what line is this one on? It's on the line x equals -2. Then it's on the line y equals 1/4. Okay, what about this point? Well, it's on the line x equals -1, so x is -1. It's on the line y equals 1, so y is 1. What about this point? It's on the line x equals -1/2, y equals 4. We've got a line for 0, but we don't have a point for 0, and that's a good thing, because we never get a point for 0 for this function. It's not defined. The reasons that we keep moving halfway and we keep moving twice and 4 times as high. Okay? Then we go halfway toward the center, 4 times as high, halfway toward the center, 4 times as high. Pretty soon we're out of the atmosphere, but we still haven't hit the y-axis. And we never do, even if we go out to the moon and the stars in the furthest galaxy. Okay? Try not to go that far though, because it's a really long trip. Okay. Then, well, the x equals 1/2, y equals 4. Now there's simple arithmetic we can do on these numbers that give us these numbers. You just do the reciprocal square. Square the number and then take its reciprocal. So that's like y equals 1/x², but I'm not even going to write that down. Now we're going to use that. But right now we're just going to get the table and understand there's arithmetic we can do that gives you these numbers. And it's pretty easy arithmetic if you understand negative exponents and stuff like that. Okay. But I don't want to get into that right now. We'll get into that real soon. Probably be an assignment due Tuesday in open math. Okay. Well, we do get into that. Okay, well, so we got that. That's the first problem. You got to be able to do that for any of these functions. If you know where to put the points and know how to label them, then it's really easy to make the table. Then we connect the table to arithmetic. Okay. You see here, we're starting with shapes, just drawing them, just subdividing things, and people are making good progress with that. I'd like to see people a little further along, but as long as you're there by the time of the test next week, it won't be that expensive. Okay. You know, each problem on the test is kind of worth 60 points. Twice with this whole quiz today. Okay. All right. Well, on the second problem, we do the same thing. We construct the functions in a 4x4 rectangle. But now the red dot isn't at the origin anymore. We sketch this thing in a 4x4 rectangle with the origin at some given point, and you don't know what that point's going to be. I will tell you on the test, I've kind of stuck. Where in the world is this camera aimed? Dude, those aims are all over here. It might have caught people coming in and out. No, it's actually over here. Okay, it's actually over there. Okay, so, okay. Somebody hold up some fingers on one or both hands. First person that holds up some fingers, I'll use it 4. Okay, now, somebody else hold up some fingers, not 4, 2. Okay, so example, let's not do the squaring function because that's one that everybody's pretty well got down. Let's not do the exponential. I don't want to do the cubing. That leaves a reciprocal function. which is something I wanted to do anyway. And the red dots at 0.168. I took your number and multiplied it by 4, so I'd have multiples of 4 here. Okay. Well, what am I doing? Well, under reciprocal function. Find the center of the square. It's still 4 by 4 square. So now I know where my x-axis is, and I know where my y-axis is. Okay, this point is 16.8. I'm not going to label it. I'll just kind of got this, and you can see that red dot. I'm making it really clear. Okay. Make sense? So we got the red dot to 16.8. All right, well, we're going to construct a reciprocal function. Well, we know how to do that. We put the red dot in the center, and we divide it in the most common way. You know, we divide it in half. That's step 1. Step 2, we divide each of these rectangles we've created in half. In step 3, we divide each of those rectangles, the ones closest to the center line, in half. Okay, we get these numbers. Okay, and then we divide it the same way vertically. Okay, we got this rectangle up here with horizontal lines. Okay, we divide it with horizontal lines. We divide this horizontal rectangle in half, and then we divide the half nearest the center in half, and then we do it down here, and we have a completely symmetrical picture. If we rotated this thing 90 degrees and didn't have the labels for X and Y on there, it would look exactly the same, right? You know, turn it this way, and then 180 degrees to 270 degrees. It's totally symmetrical. With right angle rotations. Okay, now we can even flip it. Let's flip it this way. We can even flip it corner to corner, or corner to corner. There's plenty of ways to flip this thing, but you know, those symmetries are kind of important. Okay, so we can label our x equals -2, and our x equals 2, and our x equals 0, and our x equals -1 here, and x equals -1/2 here, and x equals 1/2 here, and x equals 1 here. Doesn't take long. Uh-oh, wait a minute. Oh, man, I got ahead of myself. Okay, we could do that if the red dot was at 0, 0, but it's not. It's at 16.8, so I'm gonna have to do all these x numbers. Well, let's think about it. Okay, pretend I didn't do what I just did. What's x here? X equals what? We'll talk about it for a minute. Got hiccups. Okay. So what's x here? Okay, I have a little trouble answering that. So I saw some confused looks, and I saw some that's, oh yeah, I know what that is. Okay, so it's kind of a mix. I said that the red dot is at the point 16.8. That means it's on the line where x equals 16 and on the line where y equals 8. That's exactly what the point 16.8 is. You really want to understand that, because you really want to understand what the coordinates of the point are telling you and be able to draw what the coordinates are telling you. Okay, so there's a lot of that. When we're labeling these things, you got to understand that. So you got to work on that if you need to. But it's not difficult. Okay. X equals 16 because that's the x coordinate of this point, 7. Okay. And on this line, y equals 8. Also, this is no longer the x-axis, and this is no longer the y-axis. I was doing this without thinking. I just did what I did over there because I was busy talking about something else. Okay? So forgive me. That was a little dumb. Okay, certainly not the x-axis and certainly not the y-axis. And what I said earlier about the x-axis and the y-axis go through the red dot, yes, that's true for your basic toolkit functions. It's not true if you're doing it in a rectangle that isn't centered at the origin. Okay, so that was a dumb statement I made. So sometimes it's hard to get something out of your head and then get it into your head. But try to get that one out. And forgive me if I deserve it. If not, just keep a grudge as long as you want to. Okay. So this is x equals 16. This is y equals 8. Okay, so if this is x equals 16, what are the dimensions of this? They're 4 by 4. Okay. Now, if there's a 4 by 4 rectangle, x equals 16 here. What's x here? And what is x here? What are your two x values? Write them down on your paper. Just write down two numbers that are your two x values. I want to see if people are understanding this. You can write them down on notebook paper, or you can use that too. It's fine. Okay, most of these didn't get both of these. Some of you got one. Okay, but it's 4 by 4 square. Well, the most common error that I saw was x equals 12 here and x equals 20 here. That's not bad, but you know, how far is it from 12 to 20? That's 8 units, right? If this is x equals 12 and this is x equals 20, this thing is 8 units wide and it's not. It's a 4 by 4 rectangle, right? So it's pretty obvious what to do now. If it's a 4 by 4 rectangle, this thing cuts it in half. So this is 2 units to the right and this is 2 units to the left, right? We need two numbers that are 4 units apart with 16 in the middle. Okay, that means one number is half that far to the right, the other number is half that far to the left. So make sure you really understand that, because that's a piece of intuition. It's sort of important in a lot of ways. Just for the whole reasoning process, also for your number sense and a lot of other things, okay? Now, the reason I'm using 4 by 4 rectangles is it gives you the standard table for the toolkit function, the same as the table you're going to end up making in your assignment for next Tuesday, okay? So it agrees with the arithmetic that you're going to see, and it's compelling. The arithmetic is very easy for all these functions, the way we set it up. The numbers are all easy, okay? But it forces you to understand those numbers. And I keep saying that, of course, people have done too much with a calculator, bypassing the whole idea of understanding numbers. There are other things you can understand with a calculator in your hand, okay? But you don't understand numbers. If you don't understand numbers, you're handicapped just in everyday life, okay? There are things that would be very good for you to be able to do and think about that you can't just because you haven't been required to understand numbers ever, okay? Not in a way that's been reinforced, because I see it again and again. People come out of the secondary schools, not the fault of their teachers, not the fault of their schools. They've got to jump through the hoops that the state says, and they fault the state a little bit for the quality of the SOL test. Okay. Made up years ago. I don't know how often it's been revised, but there's been a lot of change in the way people learn things over that time. It wasn't a good test to start with. It does something well, but number sense just isn't there. It's never tested. Okay, off my soapbox and back to this. And don't ask me how to solve that problem. That's a political problem, so it's never going to get solved. Tell me what the Y numbers are. Write them down for me. You don't have to put them in a picture, just write two numbers in your paper. Then if you want to put them in a picture, go ahead. Okay, so this would be Y equals 6. Y equals 10. It's 4 units. This y equals 8 cuts it in half, so it's 2 above, 2 below. Okay, so you should always be able to do that. Okay, well. We sketch the graph, start to left. I'm not gonna even go over the algorithm. Just because we're short on time, I'd be glad to say it. Start at the point in the left edge, just below the center line. Right one, down one, over one, down one. Start at the vertical line just to the right of the center on the top edge, over one, down one, over one, down one. There you have it. And you don't join anything over here to over here. Because again, you're moving twice as close to the center line and twice as far from X every time, from the horizontal center line every time. That would continue forever. You'd be out to the next galaxy, not as quick as you would for this function, but you'd be out there. Okay. Okay. Then we make the table, which I'm just going to write down quickly. X is 14. Y is what? Well, I didn't label them all, but that's 10. This is 9. This is 8.5. This is 7.5. This is 7. And this is 6. So our X coordinates are 14, 15, 16, 15.5. 16.5, 17, 18. I didn't have time to label my X's, but that should be obvious. Our Y's are then 7.5, 7, 6, 10, 9, 8.5. These satisfy the equation y equals 1 over quantity x minus 16 plus 8. On this series, I give you the function. On the next series, it's up to you to figure out what the function is. Okay? And we'll talk about that next time.